When we talk about Java as a language, that we're learning a language right now, that's not a figure of speech. That's reality. It's helpful to think about what types of features Java has in common with other languages that we might be more familiar with. First off, Java has clearly a vocabulary. All the words and symbols in a language. It has punctuation, it has letters, it has numbers, it also has syntax. Right? Syntax are the actual rules that the language has to follow when you're combining words into statements. In English, those are pretty straightforward. You have to have a period at the end of every sentence. Hi, my name is Danny. How are you doing? I'm fine. Thanks. Aren't I great at writing? Thank you very much. Horrible, senseless, useless. Another rule syntactically is every sentence has to have a verb. Sunday, I college. Nothing. There's nothing there. Same in a programming language. In Java, here are a couple of examples. Right? The multiplication sign and the division sign can't be adjacent to each other. Pretty basic. Parentheses have to be in matching pairs. These are syntactic rules that we have to follow in order to have actually intelligible Java code. So we talked about vocabulary, we talked about syntax. Semantics is a third feature. Those are the rules that we use for interpreting the statements. So an example here is if you remember this snippet of code from the temperature converter, there are semantic rules that Java follows. And most notably here, that's the order of operations. So just to recap, those three features, the vocabulary, all the words and symbols in the language, the syntax, all the rules that we use to combine those words into statements, and semantics, the rules for how we make meaning from those statements. So those are some similarities between Java and natural language like English. There are some key differences. Java programming languages are very small, way less vocabulary than in English. They're rigid. Your syntax has to be exactly right or the compiler can't make sense of it. Unless they're literal. They do exactly what you do. If you remember those headlines from the very first Intro to Java video, those ambiguous headlines, those are possible in natural languages, but they're really not possible in Java because we always take the most literal meaning. So it's helpful to know those things, and at this point we can start diving into some of the actual syntax and language basics. So let's talk about some of the data types, numbers, and literals. We'll see what those mean. We can basically represent any kind of data. These are just a small sampling of the many things we can represent. Numbers, characters, words, even more complex things, images, sounds, videos, obviously. And basically we split these into two buckets. One we call primitive data types, and those are our sort of simplest data types, integers, doubles, and so on. The other are objects, and these, like we said before, we often conceive of them as bigger. These are more complex oftentimes. So primitive data types, we've seen these all over the place, right? Integers, floating point numbers, that means int and double. Those are the two data types we've seen so far. Characters, uppercase A, uppercase B, lowercase a, the dollar sign, Boolean values, true and false. These are all the most basic kinds of data that there are. There's a ton more, but these are the ones we're going to focus on as primitive data types. Objects are a little more complex. There's as many different types of objects as there are classes that are defined, and there are infinite classes because we define them. So there's a car, there's a scanner, there's a student, there's a teacher. We could define a different type of student if we wanted to. We can basically do anything. We've seen some of the differences already between using primitive data types and objects. Primitives being, again, numbers like integers and doubles and also characters, and objects being those user-defined types like scanner, or that tend to be a little bit more complex. Here's the key difference in how we use them. Primitive data types we combine using operators, plus, times, modulus, divided by, and so on. But objects first have to be instantiated. That's what you can see in this line here. I'm instantiating a new wrapper object called Drake. And finally, the way we use that wrapper object is by calling one of its methods, countStacks. There's a few different types of primitive data types that we use for numbers. You can see them listed here. The yellow ones are the ones we're going to focus on in this course and the ones we're going to use most commonly. But they range from small to pretty large, and they have a bunch of different uses. So here you can see byte, short, int, long, float, and double. You can see how many bytes they take up. Remember, a byte is just 8 bits all in a line. So this 1 byte variable, which is a byte, that takes up 8 bits. 2 bytes, that means 16 bits, 16 zeros and ones. We can see their potential ranges, and we can see what kind of numbers they actually hold effectively. We define literals basically in contrast to variables. Variables can change. Their values can change. Literals cannot change. If you think about 5 or 9.0 or this string enter degrees in Fahrenheit or true and false, those are Boolean literals. These are values that just don't change. You're not going to change the value of 5. That's why we call it a literal. We just take it at face value. So before you close up shop today, a couple things you want to make sure you have a handle of. You want to know what are the two main buckets of data that we use. You want to know how do we use primitives versus how do we use objects. And again, that really means using primitives with operators and instantiating objects and then calling methods. So that's really the key difference. We want to know what are the main data types we're going to use for integer values and floating point values. Again, that's int and double. We want to know what exactly is a literal and how is it different from a variable? What are some examples of literals? And then you should be all set. See you next time.